Welcome back, physics students. It's time to talk about something called potential energy. So there's various types of potential energy, so there's going to be a lot of subcategories we're going to discuss, but there's really only one type of potential energy that we are going to study in depth in this unit. So starting off, we're going to start with that question that I posed to you on the page prior to this one. So without further ado, here's my explanation.
We're going to discuss the difference between these two pictures. So we've got on the left a ball that is raised above the ground, and then on the right we've got a ball that is on the ground. Now since these are both pictures, they're just snapshots in time, there is no motion happening. These aren't videos, they're pictures, so there's no motion. And first thing we want to do is spot the differences between the two pictures. So first I noticed that, hey, this ball is above the ground, this ball is on the ground. Now I want to think about that, and as I'm thinking, I'm asking myself, well, if we could unfreeze the picture, what would happen, right? We know that right now it's just a snapshot, but what if it wasn't? Well, I might say, well, if there's nothing stopping this ball, it's probably going to drop. Okay. This one is already on the ground, so it's probably just going to sit still. Now that's going to become something really important for us, okay? Because our question is, what's the difference? Well, we found the difference. One's above the ground, one's on the ground. And then we're told that one of them has this thing called potential energy. And one of them doesn't have that potential energy, okay? And so I'm asking myself, why do I think that? Well, just looking at what I know, I think that one must have potential energy because it's off the ground, because right now that's the only difference I can see. And also, thinking about what might happen if we unfroze these objects. If we unfroze them, the one sitting on the ground is going to continue to sit on the ground. Nothing is going to happen. The one floating in the air, if we unfreeze it, it's going to drop. And so the ability of that object to change its motion has something to do with that potential energy. That is linked. So I'm going to answer, why do you think one has potential energy and the other does not? I think that the one on the left has potential energy because it is above the ground, and because if I unfreeze it, its motion is going to change. The one on the ground, its motion isn't going to change when I unfreeze it, so that's why I think it doesn't have potential energy.
All right, so that's my explanation of that question. So now we're going to talk about just the basics of potential energy. Potential energy is energy stored in an object. So it's any energy that is currently locked away, not being used. I'd like you to, right now, pause the video, brainstorm a list of different things that you know store energy. All right, hopefully you paused the video and you've got that nice list. I'm going to share with you a couple of things on my list. Things that I know that store energy. If I were to draw back a bow, now that string is storing energy, I know it's storing energy because as soon as I let it go, it's going to snap back into place. Okay. Another thing that I know stores energy, like that ball in the previous problem, if I lift up the ball and then I drop the ball, it is going to want to come back down to earth. And so that is also going to be stored energy. It wants to return to its equilibrium or its rest position, okay? A couple other things that store energy that we're not going to go into depth in today, fossil fuels, food, batteries, those three all have potential energy. However, that's going to be a chemical potential energy. And today we're going to talk about energy that has to do with things moving, because that's more of our wheelhouse here in physics. All right, so specifically, we are going to go into depth about that type of energy when we lifted something up, like my pen here, and it falls back to Earth as soon as I release it. So why does that object fall back to Earth? It has a very specific type of potential energy called gravitational potential energy. So what gravitational potential energy is it's that object wanting to get down to its rest position here on Earth. Okay, and so we measure this by taking the weight of the object, right? So weight of my pen times the height that it was above a reference position. In this case, I would be referencing my desk because that is where it's going to end up. However, I could also reference the floor and drop it on the floor next to me. All right, so gravitational potential energy is based on weight times height. We've talked about height. It's how high up it is above whatever it's dropping to, right? So the object, my pen, for example, that I use, dropping to the table. So if I took a ruler and I measured how high up my pen is above my desk, that's height, okay? Then we want to talk about weight. Weight is the force of gravity on an object. When you step on a scale, you are not measuring your mass, you are measuring the force of gravity holding you to this earth. That's why if you went to the moon and you stepped on a scale, you would weigh less because there's less of a force of gravity on the moon, okay? And so weight is going to be your mass, which is in kilograms, times the acceleration due to gravity. And we know here on Earth that the acceleration due to gravity is 9.8 meters per second squared, right? We've talked about that when we talked about egg drop. We talked about that in free fall. We talked about that with projectiles. Whenever we're here on Earth, gravity pulls us down with an acceleration of 9.8 meters per second squared. Because we talk about gravity so much, we even gave it its own variable. We use the letter lowercase g to stand for gravity, 9.8 meters per second squared here on Earth. So here is the equation for gravitational potential energy. All right, another really important thing to note about gravitational potential energy and just potential energy in general is that a lot of times we don't care about an object's potential energy until it changes. So we're going to talk about the change in potential energy, specifically the change in gravitational potential energy. So a lot of times I'm going to ask you, what is the object's change in potential energy? And what that allows you to do is set a reference point. So as I was talking about my pen, and I said the height is the pen above the table. That's because the pen goes from above the table to on the table, and I can say the table is height 0, which tells me that the change in gravitational potential energy is the energy up here minus the energy down here. That's the change. So it makes my life a lot easier when I say that, oh, the bottom point is just going to be a height of 0. Then I don't have to calculate 2 gravitational potential energies, only 1, right? Because anything minus 0 is itself. So that's going to really simplify the math for us, being able to choose where a height of 0 happens to be. A lot of times we're going to say height of 0 is the ground, or we're going to say it's on a table if we're doing a lab experiment. And those are the 2 most common places for a height of 0 to exist.